Okay, you're asked to find the derivative of this function right here, which contains an integral symbol. Rather than looking at this specific problem first, let's look at another simpler example. Applying the fundamental theorem of calculus, which is this guy right here, part 2. We're going to find an antiderivative of this and then plug in b minus f of a, and then we're actually going to take the derivative of what we end up with and see if there's a shortcut. So here we're going to use 3t squared dt as the integrand from a to x, where a is a constant. If we find an antiderivative of 3t squared, it's t cubed. And we're going to evaluate from a to x using the part 2 of the fundamental theorem of calculus. We're going to put x in for t. We get x cubed minus a cubed, where a cubed is, of course, a constant. If I want to find the derivative of this, I'll apply the power rule. 3 times x, the quantity squared, minus 0. Now the question is, do you see how to get the derivative just by looking at this integral right here? Well, the idea is that you can just substitute this x for that t, and you'll get the derivative of this function. Here's a second example. This time we're going to have the upper limit be 2x. So when I put a 2x quantity cubed and find the derivative using the power rule, I'll move the 3 down front, reduce the exponent by 1, but then I have to multiply by the derivative of the inside to apply the chain rule. We could simplify this, but I'll just leave it like it is for right now. The question is, how can you get from here to here without actually finding the antiderivative? Well, you can put 2x in for this t, so you have 3 times 2x, the quantity squared, but then you have to remember to multiply by the derivative of the inside, the chain rule. Okay. Here's another example. This time the upper limit is x squared. Same deal, x squared, the quantity cubed, minus a cubed is a constant. To find f prime, we'd move this 3 down front, reduce the exponent by 1, multiply by the derivative of the inside, which is 2x. How can we get to there directly from here? Put 3 in for that t. 3 times, put x squared in for that t rather, but then multiply by the derivative of the inside. And we get the same thing. Now what if we have functions of x at both the lower and upper limit? Same idea. We end up with the antiderivative, evaluated from 2x to x squared, put the 2x squared in for t, put the 2x in for t. Key is to remember the chain rule. And of course, we have to remember that it's x squared for the t, minus, put in the 2x for the t. I'll leave that to you. So instead of doing this problem right here, which is so easy now, we just put x in for the t, the antiderivative. It's the square root of 1 plus x squared. That's it. But let's suppose this was a 5x cubed. By the way, finding the antiderivative of this is really messy. It's something like 1/2 x, t times the square root of 1 plus t squared plus ln of t plus the square root of 1 plus t squared. That's what the antiderivative looks like. And then taking the derivative would be pretty messy. Okay, but it's easy to find the derivative from here. Just put 5x cubed in for the t. There's the 5x cubed, replacing the t, but then you have to remember to multiply by the derivative of what we just substituted, 15x squared. Okay, hopefully that gives you an idea of how to do these. If you have any questions, post a comment.